Welcome, everybody, to our talk on building second screen apps that integrate with Google TV. My name is Paul Saxman. I'm a senior developer advocate at Google on the Google TV team. And with me today is...
I'm Dave Fisher. I'm actually a faculty member. I work at a college in Indiana, and I'm on my sabbatical, and I've been working at Google for the last year or so. And then in the fall, I'm going to go back to teaching.
Cool. So Paul Saxman, Dr. Fisher. And if you guys want to follow along today, we got the a Go link up on the top there to actually get to the slides. They're going to stay there indefinitely, too, so if you want to check them out afterwards, you can go check them out. So you're all probably familiar with this type of TV viewing experience here. For the sake of this conversation, we're going to call him Mr. Leanback. I can see some of you today are kind of in the leanback mode as well, probably because it's second day, Google I/O, you guys had your lunch. So this is a fairly common TV viewing kind of arrangement. And so Mr. Leanback, let's say he comes home from kind of a long day at work, or he's been outside, with activities. And so he grabs his favorite beverage, he grabs his remote control, and then he goes into what we call the leanback mode, which is approximately 45 degrees from the floor. If you're any more than 45, or let's say any less than 45-degree angle from the floor, you're no longer in leanback mode, that's lay down mode. And we're not going to talk about lay down mode today. But so the thing about the leanback mode, or what Mr. Leanback is, the way he's watching TV, is that this is a fairly common way to watch television. This is exactly why when we talk about developing apps for Google TV, we give you UI guidelines about kind of toning down the user interface, put less information, make the interface a lot easier to use, support D-pad navigation, because obviously Mr. Leanback is not going to want to put his drink down to use the remote two-handed. And this is also why, when we designed Google TV, we put apps on there or we provided services like Quick Search and the TV and Movies application, which allows users to actually really quickly and easily get access to content. Because they don't want to, necessarily need the overload of navigating through a list of 200+ channels to find what they want to watch. They can just search for it or actually launch the app and browse for it. However, there's a lot of data coming out recently that actually paints a slightly different picture of the way that we interact with TVs. This is something from Nielsen. It was actually just published the end of last year. And they found that about 90% of tablet owner and smartphone owners actually use their devices while watching television. And the way they did this, actually, they broke it down into how often they use their device. They said do it monthly, daily, weekly, multiple times daily. And it was actually heavily skewed towards daily usage. So most users, 90% of users or more, actually use their devices while they're watching TV. And I'm sure that's probably the same with most of us. So the interesting thing, too, about like smartphones now is that as more people have smartphones and tablet devices, they're actually designed for pushing information to the user, as opposed to, let's say, other devices like computers or laptops, where it's more the user actually is driving. So smartphones, for example, if you're watching a movie and you get a text message that comes in, or you get a Google Talk, or you get an email that comes in, you're more likely nowadays to pick up your phone and start interacting with it while you're watching TV. So this whole idea of like multi-screen or second screen interaction is kind of new and very much on the rise. So we actually conducted a study very recently. This is at the beginning of this year, and we surveyed people that actually actively use Google TV, haven't actively used Google TV devices, and asked them, do you have certain devices, other connected devices in your homes? And we found that actually 92% of these homes have laptops, and a very large number, 90%, also have smartphones. And actually, the large majority of them also have desktop computers as well, desktop and laptop or tablet computers as well. So we see there's actually quite a few. Given this data with the data in the previous slide, we can see that the probability of somebody actually having and using a second screen device in their living room while they're watching TV is actually very, very high. It's well into the majority of people. So there's actually, what you may think it is now is like, this situation here, and we're going to call her Miss Multi-Screen. So not only does Miss Multi-Screen have her snack and her remote control, but also now in the living room she has her laptop and smartphone, and most likely actually has a tablet computer as well. And this whole idea of like kind of multi-screen interaction, or actually what we'll call this kind of multitasking, for lack of a better word, is that this isn't a new idea. I mean, people have been doing this for quite a few years. Just a few years back, instead of a smartphone, she probably had a feature phone, or even a few years before that, she might have had a cordless phone. Or maybe if you're like my family, you might have had a corded phone, but you had one of those 20-foot, curly cables on there that was kind of stretched out, just so that you could sit on the living room, or in the living room while you're talking on the phone. And so the interesting thing about this, though, is that really like the portable devices are really on the rise. So smartphones are on the rise. We see that laptop computer usage, people are transitioning from desktop computers to laptop computers. So really this scenario of kind of the multi-screen or multi-devices in the living room is pretty much here. So in the same study that we conducted before about what percentage of users actually have other devices, we also asked them how many devices they have. And we found some pretty interesting numbers. About two, on average, they have about 2 laptops, which is pretty surprising because most of these homes are just over, they're about 2.5 to 3 people. So you can say that either most of the adults in the home, or most people in the home actually have access to a laptop computer. Same thing with smartphones. Desktops and tablets, these are actually 1 per home on average for people that actively use Google TV devices. And we actually found that there's a median of 6 devices, connected devices in these homes. And when I first read that, I was kind of shocked. I was like, 6 devices connected in the living room, or not just in the living room, but in their homes, is pretty high. But when I started to count kind of all the connected devices that I have in my home, it ended up a lot higher than 12, or a lot higher than 6. It was actually around 12 to 15, depending on if I had my work computer at home or not, or my work devices at home as well. So there's a number of connected devices that people can use to connect to their TVs. And this number, this median number of 6, I mean, it doesn't just include smartphones and tablets, desktops and laptops, but it also includes things like set-top boxes, media devices, and that type of thing. So I challenge you to actually count the number of connected devices you have in your homes. I think you probably got about 4 of them here at Google I/O, so you can add those to your number, and you'll probably come out to a pretty astronomical number. So this is actually, given all these numbers that I've presented, this is kind of maybe a slightly more typical arrangement for being in the living room. I mean, Miss Multi-Screen was a little bit of an exaggeration. We're going to call this team more typical. And what we kind of expect to see in the living room these days is that you have to remember that the TV viewing experience is a social experience. So chances are there's probably multiple people in there. It's not always the case where people are having a shared TV viewing experience, but it commonly is the case. You can definitely expect that there's 1 or more laptops available. For a group this size, there's probably a couple. People don't always take their laptops over to their friend's house if they're going to watch a TV show, but that certainly does happen if they're maybe doing some study work and then they're switching over to watching TV later. Or if you're like me when I was in school, watching TV and using the computer at the same time, which my parents always hated. But they can also, you kind of expect that people have at least 1 tablet per household for people that are Google TV users and owners. And for a group this size, probably approximately 3 smartphones. So there's a number of different types of configurations, a number of different ways that people can use devices to interact with the TV. So really the opportunity for developers like yourselves is that people really want to do more than just watch TV. I mean, they really want to start interacting with TV. And the way they can interact with the TV is they can use their physical remote control, which nowadays they're pretty elaborate. They have keyboards on them, they have D-pads, some of them have touchpads or gyroscopic sensors. Or you can actually give them the ability to actually use their devices that they have and that they're using in their homes to actually interact with the TV. So start thinking about how you'd use their smartphones, their tablets, their laptop computers. A number of different things that they can do to interact with TV nowadays. And the other thing is that you can also take advantage of the fact that both of these markets, the smart TV market and the second screen, or let's say the handheld portable device markets, are actually very, very much on the rise. I mean, as we heard yesterday, there's, I think, 400 million Android activations now. And that's 1 million activations a day. So the number of people that actually have access to second screen devices in the home is constantly going up, and is going up at a pretty rapid rate. And the other thing is that smart TVs are also on the rise. It's projected that by about 2015, there's going to be about 500 million LCD TVs that have shipped with internet connectivity. And that is just LCD TVs that are shipped with connectivity. It doesn't include devices that actually are connected to the internet with a set-top box or another device. So the number of devices, smart TV devices or connected TV devices on the market in the next few years are definitely going up. So it's definitely a great time to kind of take advantage of all this kind of arrangement. So to kind of pique your creativity, I'll give you a few examples of developers that are building second screen apps now, or applications that are second screen apps. And for example, this one here, this is the Able Remote. The developer of Able Remote, he took the Google TV remote control application that we launched open source last year. He added a number of really great features. It still actually is a universal remote control. It has all universal remote control functionality, like the original application. But he added things like you can favorite channels and actually quickly change channels using the device. So if you're like me, you have 200 channels, but you really only watch about 5. This makes it kind of brainless to actually get to your favorite shows. He has the same functionality with applications and websites as well. So if you have a favorite application on the device, if you have a favorite website on the device, you can actually get to it in just a few clicks on your handheld device. Then he also built in some really interesting integration with Google Music. It's a widget on your handheld device that can actually control the playback on Google Music. The Peel Smart Remote app, they're actually in the sandbox today, so if you haven't had a chance to see their application, now's a good time. The Peel Smart Remote app is a TV and movies discovery app with some ties into social ties. So the integration, the way that it integrates with Google TV, like Able Remote, they actually give you the ability to control your TV with your handheld device. So if you've actually launched into a VOD service on Google TV, let's say like Netflix, you actually can get play controls, and you can actually get navigation controls as well. So if you're in the application, you can navigate around, get more information about the show you're watching. You can actually navigate out of the application as well and use the device or use the Peel app to navigate the Google TV interface. On the left-hand side, this is actually their handheld or their phone application. On the right-hand side is the tablet version. Trivialist is actually a little bit different. So Trivialist is not a remote control application. So on the right-hand side is actually the TV application. So what they've done is they've built a trivia application. They're putting that on Google TV devices, and they're putting those Google TV devices in sports bars. You go into a sports bar. If you don't already have the Trivialist app, you can see that you have the opportunity to download it. You put it on your smartphone, and then you can actually play trivia with other people in the room or other people at the sports bar. The interesting thing about this application on a technological side is that they're not actually communicating from the handheld device to the Google TV device. They're actually using the cloud. So any command, or when you make decisions on the phone, it actually sends it up to the cloud. When it's time to change the question, actually that's being pushed down to your phone as well. So the communication is not direct. And obviously the reason for that is that not all sports bars have open networks, so you can't really rely on phone to device or phone to TV communication directly. And last but not least, Mobile. Mobile actually was at Google I/O last year with us. They're also at Google I/O with us this year, and I think they're in the Google TV Lounge now. So they actually have Android and web-based multi-screen applications and APIs that integrate with Google TV. They're the applications that, on the right-hand side here, this is the Poker Fun game, which is really cool. You can play poker with multiple of your friends in your living room, or actually, I think it actually works now with people in other living rooms as well. And you have your personal experience on your handheld device, and the TV actually has a shared experience, which is the poker table. They have WeDraw and WeTelly as well. These work with their APIs, the Cloud Connect and the Direct Connect platforms or APIs for both cloud-based and direct communication with the Google TV device. And they also have what they call the Control TV platform or the controller, which actually puts all the apps into one handheld control. So the goal for us today, so now that you hopefully are kind of inspired to build second screen apps, we're going to teach you what you need to know to start building these applications. And to do that, we're first going to teach you how to share data, so basically share any data between a second screen and a first screen device. Then we're going to talk a little bit about the Anymote Protocol and library for sending input events specifically from the second screen to the first screen, or to Google TV. And then we're going to show you how to implement the Chrome extension using Anymote for actually controlling Google TV. And that's Dave's specialty. So onto the technical side of things. So like I said, I'm going to tell you how to share any data between second screen and first screen, our Google TV devices. And to do that, I'm going to do a quick demo to kind of show you what I mean. This demo, what we did is we put together a few demos for using sensor information. So the handheld device actually becomes a kind of a sensor proxy for the TV. So what we'll do is we're going to bring up the sensor application on the TV. These are just demos. I mean, they're very simple applications, but hopefully it'll kind of give you an idea of what's possible when you can just basically pass any data between the two devices. And, oops, so to launch that. So this is called the remote sensor data. So we took some of the sensor demos that we had for Android. We ported them to Google TV. This is actually the colored cube example that you can get for your Android devices. And so what I'm going to do now is I'm going to pair my handheld device with the Google TV. This pairing, it's a little bit dark, but I hope you could see it. So the pairing process can be automatic. There's technologies that can make it automatic, but let's see if I'm paired already. Nope. So I'll find Google TVs. So what I'm going to do is, since we don't have auto pairing on this network, I'm actually just going to enter the IP address real quick. And this is kind of a one-time process because next time I try to connect, it should automatically be there. And we conveniently put the IP address on the display so that you can quickly launch this. So, and 130. Okay, so now I'm going to, on the phone, I'm going to launch the colored cubes interface. So you probably recognize this from Android phones as one of the Android samples. And what we're doing now is basically the handheld device has become a proxy. So any of the sensor commands on the handheld device are just sent directly across to the television. So if I pick this up, you won't be able to see it anymore. But as I rotate the phone around, it actually rotates the cube. And the first time I actually ran this demo, I was a little bit confused because as I rotate the phone, let's say to the left, actually the cube rotates to the right. It doesn't seems like the perspective's a little bit backwards. But what it's actually doing is on the phone, since you're looking into the screen, you're actually, when you rotate the handheld device, you're actually kind of rotating your perspective of the cube. And we actually maintain that type of perspective. But you'd actually think when I rotate the phone down, you might want to rotate the cube down. Just a copy it if you try to do this yourself. I'll give one more quick demo, and then we'll move on. Oops. And we also took the sensor graph demo. And let's see if I can click that. Yep. So this is also one of the Android examples. We also ported it to TV. And this is kind of to show that we're taking pretty much all the main sensors. I think we're taking a accelerometer, the gyroscope, and the orientation sensors. And we're just actually passing all that information to the TV and rendering it here. So you see if I pick up the phone, if I start to rotate it, move it around. So all that information is being sent back pretty much real time. We haven't necessarily benchmarked it because a lot of it depends really on kind of the nature of the network. But you can kind of, with the technology we're using, I mean, it's really low-level UDP communication. You can pretty much guarantee it's full-time or real-time communication. So, and actually, as the phone goes to sleep, it actually sends the disconnect command. So that's why we just saw it go away there. So now we'll talk a little bit of how you can actually implement something like that on Google TV. So back to the slides. Oh, thanks, Dave. Oops. Okay, we got the demo. So this is the do-it-yourself version. So if you wanted to actually build pretty much that same application from scratch, like I said, we actually, Google TV devices all broadcast using MDNS and Anymote TCP local service. So if you want to find devices, Google TV devices, on somebody's home network, all you really do is you search for this Anymote TCP local using MDNS. Once you actually find it, you can actually extract out the name of the device, the IP address, and the port. The port is actually for the Anymote service, which we'll talk about a little bit later. But this is actually a quick and easy way to actually get access to the device or find devices on the network. So this, the example code here, this is actually using the JMDNS library. We'd highly recommend that you use library to do this, otherwise you actually have to build a MDNS client from scratch, which could be a lot of fun, but it could also be a lot of work. So starting a service on a device in Android world, or in Java in general, you can rely on the java.net libraries. It's fairly straightforward to open up a server socket, bind it to a port, and actually start communication. So here, we have an example. We're starting the server socket on port 1337. We have a loop here because what ends up happening is you block for communication. Once a connection is made, you unblock. Once the socket is closed or you finish your communication, then you can go back to a reset state. So you're waiting for communication again. So like I said, the opening of the socket, that blocks until the communication accepted. And then you have to implement a couple of methods for reading data and writing data from the input and output streams. Likewise, the connect to the service using the java.net libraries is very straightforward. You open up your socket, you pass it the IP address and the port. You write and read your data. Writing and reading data, you're streaming data back and forth to the, using the input and output ports. You close your socket. If you want to port this to an Android application and productize it, though, things get a lot more, we'll say, serious. So when you open up the socket communication, the port may already be used. I mean, don't take this slide too seriously. I mean, I actually went through and tried this, built this application out from scratch using the sensor APIs. So these are actually real to-dos, but we'll get to the point of why, I put this slide up here in a minute. But you have to worry about things. Is the port already used? How do you handle the exceptions? Because there's a lot of exceptions that can be thrown at various places. With Android, you can't do any UI on or you can't do any network on the UI thread, so you obviously have to spawn off threads. And in this situation, you probably want to spawn off a couple of threads. One thread to actually do the network off of the UI thread, and another thread to actually do I/O, so that you can open up your communication for a second device to communicate at the same time, because they both use the same socket. And a little bit more, so another really important thing to remember is that reading and writing data, if you want to read and write structured data, you need some way to actually serialize and deserialize that data. And that actually has to be the same on both sides. You have to have kind of a mirroring of the serialization and deserialization. So if you're using one technology to serialize the data on the handheld device, you need to use the same technology or similar technology to deserialize it. Likewise, with actually opening up the socket connection. When you port this to a production Android device, there's a lot more work that needs to go into it. The biggest one is actually sometimes MDNS doesn't work. For example, a lot of corporate networks, they block MDNS. Most users' home networks don't, however. But you may want to give the user the ability to enter an IP address, which requires you to open up a dialog or some type of user interface. You have to start the threads, et cetera, to actually do the communication. So there's a lot more work. Socket communication is a lot of fun. Like I said, I went through building an application from scratch. It does everything in socket communication. I had something that was reasonably well working after a couple hundred lines of code. When I started to put a little bit more of the Android framework in there about the UI to allow people to actually manually enter, I was up to maybe about 500 lines of code. It took me a couple of days to actually get it in good working order. So to kind of help developers kind of not have to go through that, all of you to go through that every time, what we've done is we put together a Google TV data sharing Android library for Android developers. We're in the process of launching this now. It's not quite out there, but it will be out there in a couple days. We're waiting for one last approval from open sourcing. So what the Google TV data sharing library does is it really simplifies for developers, Android developers, the process of finding and sharing data with Google TV. It is built on a client-server kind of infrastructure or architecture, and both libraries are actually in one package, and they actually work almost the same way. So actually, I'll go over a little bit of the code, but the code works on both sides relatively the same way. So the library actually deals with things like the service discovery and pairing. It includes the UI. The library is open source, so if you don't like the UI the way it is, you can obviously tweak it. It deals with the socket communication, and that includes the threading and the exception handling. That also deals with the deserialization, data serialization and deserialization using protocol buffers, which is a really lightweight protocol and language agnostic protocol for deserializing and serializing data. It's part of the way that we actually get the really low latency latency communication. And in this library, we baked in a few things like the reference messages, which include registration. That tells you when the device is connected, disconnected, and pinging the device. Sensor data, so the sensor demo that I gave you, we have the protocol buffers in there for sending sensor data. And it's not the entire suite because it seems like there's a new sensor almost every day with Android. But we got most of the main ones. And if your favorite sensor is not in there, you're absolutely free to add it in there. And generic data, that's basically just strings. So if you have serialized data on your second screen device and you want to send, like, for example, JSON or XML, and you want to send that to your first screen device, you can actually just package it into a string, send it across, and actually deserialize your JSON or XML or whatever your favorite string-based data serialization format is. So it's really kind of implementing this is pretty straightforward. You're going to And this is actually going to be a lot of code in the next few sections, so hopefully, this was an advanced course, so hopefully you're waiting for a little bit of code. But so you actually implement this callback lister, just two simple methods, one for dealing with errors, one for dealing with the data coming back. Oh, and by the way, don't worry about like copying all this down. This is all going to go out in our documentation, so it's mostly cut and paste. And I think most of it's actually in an activity that you can implement or extend yourself, what we'll call the data sharing activity, so which will simplify things. But if you want to use this code, the most flexible way you want to implement this activity. So you want to implement a service connection so that you can attach your callback listener, which was your activity, to the data sharing client. And that's basically this line right here. So once the service the service is connected, the service is actually what does the communication, which you don't have to implement. But once the service is connected, you attach your client listener to the data service, and that's how you get these callbacks on error and on response data. And likewise, when the service is disconnected, you want to shut things down so that you're no longer listening for results. And then you start your intent, or you start the service, and this actually gets things going. So this actually kicks off the pairing process, which includes things like the user interface for doing the pairing. It does the whole MDNS, scanning the network as well, and we'll give the user interface if there's multiple devices on the network. So pretty much it. And from that point on, it's just a matter of actually sending your messages in your code. So protocol buffers, the way it works is you take a protocol buffer definition. You convert that into a Java class if you're programming in Java, but it is language agnostic, so you can basically turn protocol buffer definition into pretty much any programming language interface implementation. But you create your protocol buffer, you add your data to the protocol buffer message, and then you just ship it, which is the last line here. So, and one last thing. So this is actually what the protocol buffer looks like. And for the sensor data, we actually made the protocol buffer look almost exactly like the Android sensor event and sensor classes. So the sensor event in Android has accuracy, the sensor information, the timestamp, and the values. We basically did the same thing. So on the receiver side, it essentially looks like you're getting a sensor event. Instead of actually an Android sensor event, that's going to be a data sharing library event, and then you actually can wire that into your user interface, pretty much like you would with a normal sensor event. Like I said, this data sharing library is actually going out relatively soon. If it's not out already, I didn't check my email in the last couple of hours, but it's going out code.google.com/p/Google TV data sharing. The link will be on the Google TV developers documentation. And the two samples that I showed you a moment ago, they're also both on there as well, so you can actually run those out of the code repository, take them, extend them, do whatever you want with them. They're pretty much your guys to play with. So that's actually sharing any data between a second screen and a first screen device or Google TV. And now I'll talk a little bit about actually Anymote, which is a little different paradigm. So the Anymote Protocol is actually what we use for the Google TV Android remote control and the iOS remote control that are available for Google TV now. So basically, the idea is that you turn your handheld device into a remote control for sending key events, touch and mouse events, and Android intents. And we'll talk a little bit more about how that works. Dave's example really kind of captures kind of the benefit of all of these. But so Anymote in itself, though, is a protocol or a specification that defines how apps can actually securely send these types of events from a first screen device, or from a second screen device to a first screen device on a user's home network. Every Google TV device has the Anymote service running, so you don't have to worry about implementing anything on the Google TV side, like you did with the sensor information or the data sharing library. So Anymote, actually, the service is running on Google TV. You're just responsible for what goes on the second screen device. And the interesting thing about the Anymote protocol, the way it works on Google TV, is that whichever app is in the foreground actually receives the Anymote events. So, so basically, if you're familiar with the Android remote control, I can use that for navigating pretty much anything on the device, or actually controlling any application on the device. And this is actually really unique in the Android world, because generally applications cannot send key events or touch events to another application. So this allows you to actually build an application on the second screen that will actually send these key events and mouse events or touch events to your another application on the Google TV device. So again, this is the client-server infrastructure. So the second screen is the client. The first screen is the server. Discovery is also via MDNS. That's the point of the MDNS Anymote protocol that we're broadcasting. The pairing protocol, since it is secure, and the reason for security is since you're sending mouse events and you're sending touch events and you're sending intents from the second screen to the first screen, you don't want just anybody sending that data across your network and controlling your TV without some kind of authentication and pairing process. The other thing is that if you're using your handheld device and you're sending key events, you don't want other people on your network necessarily sniffing those key events, because you could be entering a password or sending confidential information from your second screen to your first screen. So there's an authentication and pairing dance that basically involves the second screen sending the request to Google TV saying, hey, I want to pair. The Google TV displays a challenge to the user on the screen. The user enters the challenge into the second screen device. The pairing happens, and then actually Google TV sends back a TLS certificate that the first screen device can use for encrypting the message. And then from that point on, once you have the certificate, you use it for just sending your events. I'm going to give you another quick demo just to show you how the pairing process works. If you have the Google TV Android remote control, you've probably seen this before, but it's a pretty straightforward process from a user's perspective. Make sure I'm on all appropriate networks. I unfortunately can't show the auto pairing just because I'm not using a, is it screen? Yeah. So I'm not using a standard network. So I'm actually going to cancel on the auto pairing. I'm going to do a manual pairing, which means that, oops, I have to get out of this demo.
You want me to bring it up for you?
Yes, please. Another cool thing about this technology is that you can have any number of devices connected to your TV. So actually Dave is bringing up all this information using his laptop, which he will talk about.
Don't look, this is what I'm going to talk about.
All right, so I'm going to do a manual pairing. Like I said, the manual pairing generally isn't required on a user's home network. It's just because we're in kind of a funky network configuration here. But this is really the pairing process where I'm actually, or the discovery process where I'm actually, finding the devices on the network. I'm going to go ahead and connect. And then this is the pairing process itself. I'm sorry, actually kind of in the front there. But this is, so the handheld device has actually sent the command to say, like, I want to pair. Google TV actually displays this to the user. I got a really easy one this time. I enter that in the phone. I hit my pairing. And then everything's done. The user is paired to the device. So now when I actually use this device here to actually navigate around, that's actually sent across to the Google TV. I can go back, I can go home. Pretty much in the Google TV Android remote control, we have pretty much everything for keyboard input, touch events, all the Android keys, et cetera, are all captured on the device. Anybody implementing this can actually send all the same events across as well. So that's pretty much it for that. So if we go back to slides. So as I said, Anymote is a specification. If you want to kind of learn about how Anymote works, you can actually go to our developer site for TV Remote. It talks about the specification, and there's actually quite a few libraries out there and open source codes. Discovery is generally handled by the second screen application itself. That's not baked into a library, but you can use something like JMDNS. Pairing and authentication, we have a reference implementation in Java that works on Android, and there's also a C++ implementation that released very, very recently. And for sending events, you actually use the Anymote Protocol reference implementation, which is also Java and C++ based applications. The libraries both use protocol buffers, the same as the sensor demo did. Here's all the URLs. Kind of the important thing about this, though, so there's a lot of things that you'd have to do to actually get started. We recognize this. This code we actually launched last year, the reference implementations, but there was still a high level of kind of a high barrier to implement that. So what we did very recently as well is we made the Google TV Anymote library for Android developers, which works really similar to the other implementation that I showed you. Basically, the major steps is you implement the client listener, you open up the service connection, you bind to the Anymote client service, you start sending events. I'm just going to kind of speed through this a little bit so Dave has enough time to give his demo. So the code is very similar to before. You're actually, you create an activity, you implement the client listener. This time you have 3 methods to implement. The most important one, obviously, though, is the onConnected, where you actually get an Anymote sender. That's the class that you use for sending the events. Same as before, you have a service connection, so you know when the Anymote service is started. And that point is when you actually pass your client listener to the service so that you actually can receive those callbacks. Then you're responsible for actually starting an intent. You can do that on your onCreate method. You can do that whenever you want, basically. You can have a pairing button on your remote or in your application. It's up to you. And for sending events, basically what you get is you use this Anymote sender to send things like key presses. This one I think is really cool. By the way, this is actually the Android key events. So you just tell it what Android key event you received, and you can pass that along. The touch handler is actually a really cool class. Basically, you pass it any view, and it turns that view into a touch surface. So I can use it to actually send touch events across to the Google TV. You can set intents, and this is actually a really powerful feature of the protocol. It allows you to actually to start up applications, or actually go to URLs, so you can send view intents for loading up Chrome, for example, or going to the Android market. You can start applications like the YouTube application and tune it to a particular video, or you can do things like start your own application. So if you've gone through the pairing process, you have an application on Google TV that you want to control, you can actually send that intent, bring your own application up on the device, and then start sending the input events across. Like I said, this library is also open source, is also available for you guys to use. Hopefully you saw it. It really simplifies how Anymote works. We have another sample with that. We have another sample with the Anymote library for playing blackjack. Pretty simple, but you guys are free to take it and run with it. And with that, I'm going to pass it on to Dave.
Cool.
Thank you, Dave.
Thank you much. 4 minutes, huh? No, 20 minutes. All right, so what I'm excited about, Paul's been telling you about how you can use phones, how you can use tablets. My world is about the laptop, right? So this actually fits me really well as a user. I'm sitting there, I'm watching TV. I've almost always got my laptop out. Maybe that's not a good thing, but that's how it is, right? So I'm going to talk to you about Anymote. That's the communication mechanism, communication from your laptop, and we're going to do it via Chrome extensions. So first off, just to kind of make sure we're all on the same page, Chrome extensions. Who here has made a Chrome extension before? All right, like 10 of us. All right, I raised my hand. How many people have used a Chrome extension before? All right, over half, excellent. So I know what my audience is. You're not really Chrome extension developers. Hopefully this will be your first one. So just a little background on what they are. You can download them from the Chrome Web Store. They add functionality to Chrome. There's a great developer site where you can learn more about making them. A couple things they can do. They can be browser actions. A browser action is basically like a small icon. So these little icons up here are browser actions, which is a little separate program. Or they can be content scripts, which adds things to the page you're looking at. So there's two kind of things I wanted to talk about today, one kind of user-facing and one developer-facing. First, we're working on a Chrome extension for communication. Not out or available yet. We're still working on it, kind of brainstorming ideas. I asked if I could give a demo today, and they said go nuts. So what this extension does is I've already paired with this TV, so I did the pairing code that Paul showed just a second ago. It's using Anymote. I can send key events, so if I wanted to send like the search command, you can see that the search box will open up. If I hit the back button, if I hit the home button, it's got all the functionality that our remote does with the buttons. It's also using your keyboard, which is really nice. So the arrow keys are probably the most useful thing. Like all of Google TV's D-pad navigable, so the arrow keys are huge. You can also type. So if I say, hello, well, I can't type, but I could type if I knew how. So those are kind of the basic key press events that you can do. But since it lives in Chrome, it actually travels along with you as you surf the web. So in this example, I'm on a Google Plus page, and if I'm looking at things on this Google Plus page, here I got sent a link to some, funny site. You decide if it's funny or not. And what I could do is if I wanted to share with the other people that are in the room with me what I just found, I can actually fling things to the TV. What it's actually doing is it's sending an intent that opens up a web page, which opens up Chrome on the TV. In addition to being able to use your keyboard and to send these special keys, you can also use your mouse. So you've got access to your keyboard and mouse, which I think is really nice. Other things it can do, go back to the Google Plus page. We can look at a page and we can say, is there anything on here that they might want to have on their TV? So here's a YouTube video. So the best screen in your house is probably your TV. So what we do is we look at the page and we say, is there anything on this page that a user would be interested in having on their TV? And we give you links to make those things quicker. So here we found this YouTube video on our page, but we send it to the TV, it just plays. You can share it with anybody in the room, which is kind of neat. It actually works wherever you go. So here we've got some YouTube videos in a Gmail. You can see that it's found those, and I could send those over. Didn't want to stop with just YouTube videos, though. We actually wanted to make this kind of like, it's a companion that travels along with you as you surf the web, right? That you can send things to the TV. So here, if you're looking at a page that's related to a TV or movie entity, what we can do is we can say, we found some TV programs on this site, and if you would like, you can actually send those over to the TV as well. It's going to open up the TV and Movies app. And then from the TV and Movies app, you can do things like you can save it to your queue if you think you want to watch it later. Or if you want to watch it now, you can see what options there are. If you had Netflix, it would show up in this list, things like that. So that's the extension that we're playing with. So what we're doing is great. And in making this tool, we're going to open source some things so that you can do your own. So really what the developer-facing announcement about is how can you make your own extension. So we're going to show you the tools that you can use. But first, why? Why would you want to do this? I've broken it up into a few categories. Maybe you're a web developer and you want to get your content to Google TV easier. Maybe you're an Android developer. How many Android developers do we have? All right, that's my audience. That's what I thought. And you want to talk to your Android app. This is a way you can make a custom remote control. Or maybe you just have some other idea. So I mean, if you're a web developer, you can make things that you can fling. If you're an Android developer, you can make like a custom remote or something that goes with your app. So it's kind of like a partner to where you could play with your Chrome extension as well. Or if you have just some other idea, there's all kinds of things you could do. Your computer knows a lot, right? And it can share this information with your TV. So how? How do you make this happen? We've got a code.google.com project that you should go visit. It's just called Google TV Chrome Extensions. There's an example in there for how you go ahead and do this pairing and communication. But there's actually one more thing. So I said I'm a college professor. I couldn't resist the opportunity to give you a homework assignment. So you've all been assigned a homework assignment. And that is the Anymote learning exercise. So the idea is you'll learn how to use this Anymote communication. And so there are two extensions. One is the example, which is finished. And then the other is the learning exercise, which is missing all the most important pieces, right? So it's the same extension, but it's missing everything that's useful. And we've broken it up into a couple of different exercises to make it easier for you to learn. Just kind of go through each step. Let's take a quick look at the example. So on the example here, what I've got is it's another browser action. What I'm going to do is I'm going to create a plugin, which I'll talk about more in a little bit, that's kind of like initializing this communication. Things you can do with Anymote is you can find TVs on the network. Here we've used Discovery. We found this TV. I've listed it by IP address. We show you how to begin the pairing process, so you can see a pairing code popped up here. So DBE1. And so now I'm paired to this TV. You pair one time, right? So if you use an extension every day for a month, you pair once at the start of the month or forever. And that's the one and only time you're going to need to pair. And then to actually communicate, you open an Anymote session. Anymote you would have to open like every day, right? So every day you would start up a new Anymote session. This would do the communication. And we've got examples in here for how you can send keys, like the home key, the search key, how you can send data. So here I sent the data hello world, just because it's kind of a hello world app. How you can do YouTube flings, which would be opening up a YouTube app. I should define the word fling. Fling really just means to send an Android intent. It doesn't mean Chrome, it just means to send an Android intent. So here I did open Chrome, but you could open YouTube, you can open the TV player, really powerful. And then the last one here is ping. This is just to test the health of the connection. So that's the solution. And these are the steps that you kind of went through in the solution. I should show you the starting point as well, way less exciting. So the starting point, if you click on any button, it just says, you know, I'm not implemented, so that's what you should do, right? Not nearly as exciting. Extensions are made up of basic web components, HTML, CSS, JavaScript. So you can see here that we've got an HTML file. This is the HTML that's going to get loaded if you click that button. So it's really like a local bookmark is another way to think about it. Some CSS, some JavaScript. Then the other thing that extensions have is a manifest file. You're Android developers, so you know the manifest file. In extensions, it's JSON instead of XML. Same idea, though. You're configuring, hey, what does this application do? So in this manifest file, I'm saying things like, I'm a browser action, so that's why I've got the icon. When you click me, open this popup.html. The other really important thing is that this extension uses a plugin. So depending on your platform, it's going to load an appropriate plugin. And it'll choose this based on your system. You don't have to worry about it. So really, there's one plugin. It'll just pick the right one. When we first realized we were going to have to use a plugin because Anymote requires a level of security with SSL communication, we were initially bummed because we'd rather stick with the web technologies. But it turned out really nice for developers. So we were forced to make a really well-encapsulated module that's really easy to use. And so that's what we're giving you today. So really, this learning exercise, it's all about how do you use the plugin, right? So that's the main thing. And it's ready to go, right? You can just steal it and you can use it. So really using this plugin. So this plugin comes down to 20 functions. So if you can call these 20 functions, you can do everything that you need to do. Paul, awesome. Paul talked a lot about like network communication, things like this. That's really exciting stuff. You should learn how to do it, but you don't have to. So this makes it really easy for you. And so we're going to use these 20 functions that are in the plugins to implement these buttons. That's what the learning exercise is all about, right? We're not going to go through all of the learning exercise today. I'd hate to steal your fun. We're just going to show you one of the steps so you can see how the flow works, right? This is going to increase the likelihood of number of people that are doing it. We just went from 10% to like 15%. So we're going to show you one button, the initialization button. What needs to happen in initialization is you need to get this plugin, which was written in C++ and compiled, accessible in JavaScript. So that's kind of the first step. And then once you make it accessible in JavaScript, you're going to make 3 clients for discovery, pairing, and Anymote. So it's a really natural breakdown. We'll go through the code extremely quickly. So right now that button just says, hey, I'm not implemented. What you're going to have to do to implement it is you're going to have to create an embed. This is kind of our bridge of a certain type. So you add that to the DOM. The embed, by the way, we've actually made visible. So when you click on this initialize button, the embed is this white square, right? So that is the embed. Usually you don't make them visible, but we did for learning purposes. And then you've got an embed element, which essentially is the plugin. You've got one crazy function to call on it. That crazy function brings you into JavaScript land, right? So pretty simple, kind of a crazy method name, but pretty simple. Then you need to initialize. So the initialization step, there's an init, and then the main thing that happens in initialization is your certificates. Your certificate is how you're identified to the TV. Once you're paired, it's that certificate which says, hey, I trust this device. It's used for encryption. Some boilerplate stuff in here, you don't have to worry about the details. But once you've got that certificate made, once you're paired, you want to hang on to that certificate. And then kind of initialization is ready to go. So you make these 3 clients: discovery, pairing, Anymote. Say it a couple times there. So we're going to stop with the exercise here, but that's kind of the first step. If you were to do discovery, pairing, and Anymote, there's some API functions for discovery, to start the pairing process, to send the response, to start the Anymote session, and to stop it. And then kind of the most important slide is once you're connected, what can you send? What can you tell the TV? Key events, obvious. Mouse events, which I showed you. Mouse wheel events for scrolling. You can actually send arbitrary data types. Right now, that means sending a string. That's how I did the hello world thing. Fling, I'll step over once. Ping is just to test the health. Without a doubt, my favorite is definitely send fling, right? Just because if you think about how Android works, how communication Android works, I mean, if you can send an intent somewhere, you can do a lot, right? And this gives us the ability to send intents. All kinds of intents you can send. I showed you the code here for flinging the page that you're currently on. Probably more fun than that, though, is if you wanted to fling YouTube, you can send a URI that will open YouTube specifically. If you wanted to open the TV player, you could send this. You could actually send parameters like channel and things like that on the TV player. If you had an app on your, that you wanted people to download on the TV, you could send a link to Market to open up your app. So it's like, hey, download the other half of this tool, right? So that one I think is useful for people. And then it's kind of crazy, but you're passing a string. But you can send almost any intent. You can send extras, URIs, you can set the category. It is kind of a crazy string format. There's a function called toURI, which creates a string if you were on an Android platform. And really, what the receiving end does is it calls parse URI. So you can send anything you want. You just have to know how to format the string. I've got some advice for how you do that in a doc that I've made. But if you were developing your own app, you would know your package name, right? You would know the names of the activities that you want to launch. And you can explicitly call those things, which is really great. So these are the 20 functions that you have to learn to use this thing. I wanted to definitely give credit to Dave Hawkey. He's my 20% hero. He wrote the C++ code that all this is built on. He also open sourced all the C++ code, which is really good if you're a C++ developer. It's all out there, everything that he used to make. C++ works on a lot of platforms. Love to see somebody run with it with iOS or to do their own thing with the C++ code. And then your next step is to go out there and do the learning exercise. Anybody going to do it? All right, show of hands. Come on. Everyone in the room just raised their hand. That was great. So that's all we've got. Well, thank you for coming.